Is my screen visible? Hmm? Is my screen visible to you?
Visible, sir.
Yeah. So today we will be looking into the next part of this third module, in which we will be discussing about the replacement decisions. Okay, what is replacement decisions? Okay, as we were discussing about maintenance and what does this maintenance has to deal with replacement. Okay, so I already told you what is maintenance, right? So maintenance is we are trying to make the machine or the equipment, uh, we are trying to bring it back to the original state and to ensure that the machine is functioning the same way what it was doing, like how it was performing before the failure. So the same thing is called as maintenance. But I also mentioned that it's not about making the equipment or the machine to run to its previous state. It also deals with the cost involved in carrying out the maintenance activity. So it is not good for us to spend more on maintenance, because in some cases it is more advisable to go with uh, replacement rather going with maintaining the equipment. For example, you have a mobile phone, the same thing I told you in the last class also. You have a mobile phone. Imagine the display of the mobile phone is gone. We know that instead of repairing or doing the maintenance activity on the display, it was always better to go for the replacement of the entire screen, or to go for the replacement, I mean completely replacing the mobile phone itself, right? So such cases exist in company also. uh, because uh, if you're replacing at regular intervals, what will happen is the overhead cost of these items will go up. Okay, if continuously, if you are repairing or carrying out the maintenance activity, in some cases the overhead cost of this or the capital, the overall cost will increase. Because of that, the capital cost will also increase, which was unplanned, right? So what we can do is we can go for replacing the particular component or the completely the machine itself. So that is what we call as replacement or the replacement policy. So what in replacement policy, what you have to consider is, what if I'm doing like the replacement policy should balance the wasted life of an item replaced before failure and cost incurred when the item fails completely during service. Okay, that is, if you're going to plan, or if you're planning to do a replacement, what you have to study is, if I'm using this product and if it goes as waste, or if it fails, it will go as waste, right? If you're using a product and if it goes as waste, what you're going to do, and what is the remaining useful of this life? Say for example, you're using a tire. The tire has some tubes. You're going to do some the puncture. If the tire gets punctured, you're going to fix the puncture, right? So how long I can manage by fixing the puncture? So that will be the remaining useful life of the tube. Or if I replace this tube now, how long I can run the vehicle without any problem at any problem. So that is what is called as replacement policy. So when and how to go for replacement is important, but we should also consider the cost that is going to incur for maintenance. And we should also consider, if I can do some maintenance and if I could run the machine for some extra long time, how it will be on, how it is beneficial. So like that, we should think on that. So one is, if I could do the maintenance and if I could run the equipment for certain period of time by extending the life of the product, okay, that is good, right? So that is very good and we can do it. Or what will happen if I completely replace? So what is the cost it's going to be incurred? So this comparison should be done. Say for example, we may have a cycle in our school days, And what our parents will try to do is we want to buy a new cycle, but the parents will tell that no, 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 you can just fix the tighten the parts, you can fix the chain on the, you can adjust the gear, do the fix the gears or the the rotating parts. Then you can run the cycle for a extra for a longer time. So that means what, they can postpone the replacement of the cycle, or they can postpone the replacement of the equipment in case of an industry. This postponing will help to avoid the extra cost what we are spending on replacing a particular product. This can even help in case of replacing a part inside a component. So as I told you, like most of us will have this experience. We know that our mobile screen is broken, but due to our economic condition, what we will do is we'll try to use the mobile phone. We'll continue try to use the mobile phone even if the screen is damaged. Okay, only to when the point reaches that no, the display, that the screen is not even working in our mobile phone. Only at that particular point, what you're trying to do, you're trying to go for the new mobile. Or then also there are some people who try just to replace the mobile screen alone, because they know that the functioning of the mobile phone is good, but still they need and they can keep using that mobile phone for a extra longer period, so that it doesn't affect their budget. Here in the case of the company, we call it the capital budget or the whole budget of the company. So that is why replacement is important, and replacement decisions are very important. Okay, so now there are three types of replacement problems. One is replacement of equipment whose efficiency deteriorates with age, such as machines, vehicles, tires, etc. Okay, and that is, you're using a component and that component becomes obsolete, like you can't use the component anymore because the component like it is aged. Will you use a Bombay lathe now? Can you use a vehicle which is more than 30 years old? Can you use a tire after some 2000 kilometers, a bike's tire? No, correct, because the life of the product is gone, and you can't keep on using the same product for a longer duration. So in that case, what you are going to do is you are going to replace the complete machine or the complete vehicle or the complete tire. You have to completely refix it. So this is when you are dealing with replacement of equipment whose efficiency deteriorates. Okay. In the second case is replacement of equipment which do not deteriorate but are rendered completely useless, such as electric bulbs, radios, etc. Here the equipment is not deteriorating, right? You're going to replace, if in case of electric bulb, the bulb is good, only the fuse has gone. After completing useful life, the bulb's fuse is gone. But you can't fix it because it's not going to be cost effective for you. So that is when the component is not completely destroyed but or completely failed. It can function, but spending on such function such replacement or fixing the, how can you be able to fix a fuse in a small uh, uh, bulb? That arc bulb is there, right? Will you be able to fix the fuse in the arc bulb? And if even if you're if it is going to be more costly than buying a new bulb. The cost of new bulb could be around some 20-30 rupees, which is no more available in electrical shops because of the LED or the other LED or bulbs. But still, if you're trying to fix the fuse in the arc bulb, which is going to be more costly than buying a new bulb, right? So that's why it is not useful. Okay, so but radio sometimes it's okay, but imagine a small transistor. To fix the transistor is more going to be more costly than buying a new radio in some cases, not always. So in that case, what you do, you know that okay, spending on this is more not required. That it is better to go for the new product. So that is when the replacement of equipment which do not deteriorate but are rendered completely useless. Okay, such as electric bulbs, radios, etc. Then we have the third type is called as replacement of equipment which become obsolete due to research and development. Like sometimes what you do know, we make some trial components. This trial components we cannot use this trial components for real time applications. So we do some randomly some testing and to fix something, like we build something and we destroy. It's a lab scale development. Mostly it will be like a lab scale development. In that cases, it's not possible for us to completely go for the using it. So what we're trying to do, we will be completely replacing that equipment which becomes obsolete due to R&D or research and development. So there are three types. Okay, so this is the three types of replacement problems. One is when the replacement you're going to replace the equipment whose efficiency deteriorates with age. Second time, which do not deteriorate but are rendered completely useless. The third case is
Sir,
absolute due to
screen is not visible, sir.
what?
Screen is not visible, sir.
Just a second. Give me a second. Okay. Now is it visible?
Yes, sir. It's not visible, sir.
Okay.
Thanks.
Yeah. So that is what is happening, right? So as I told you, we are trying to replace the equipment whose efficiency deteriorates with age and time, like the machines or the vehicles or the tires. Then we discussed about replacement of equipment which do not deteriorate but rendered completely useless, like electric bulbs, radios, etc. Then we discussed about the replacement of equipment which becomes obsolete due to research and development. Due to R&D, some equipments are not working, right? You have to go for complete replacement. Because of continuous testing, other things, that component could be failed. So it is better to go for a new component. So these are the three times when we are planning to go for replacement of a machine or an equipment. Okay. Now we will solve some two problems with replacement strategy, and these problems will be there for your FAT and CAT exam, midterm and FAT exam, final examinations. Okay, so what is this? First is what we're trying to do. First is replacement strategy for equipment which deteriorates gradually. Like I told you, due to aging, the component can get fail, such as equipment, machines. Okay, so this equipments and machines should be replaced at an appropriate interval of time. Okay, because the lifetime of the product is done. Say they say, the lifetime of a mobile phone is maximum of 3-4 years, and the fourth year, absolutely, we are forced to replace our mobile phones, right? So this is what, because the due to continuous usage, the mobile phones can deteriorate, or it can fail to a certain period. So that's why for most of the electronic components, they give warranty of up to 1 year or 2 years, not more than that. Okay, so but for to solve this, we are going to have some assumptions. Okay, we are going to have some assumptions. Okay, so what is the first assumption we are going to make? The first assumption is, initially it is assumed that there is no time value of money. Okay, you should understand this. What is this time? No time value of money first. So say for example, now I'm giving you some 100 rupees. Okay, what will be the value of this 100 rupees today? Can you answer this? Today I'm giving you some 100 rupees. What is the value of this 100 rupees today? Hmm? Am I audible?
Yes, sir.
I'm giving you 100 rupees today. What is the value of this now?
100 only, sir.
100 only. Okay. So today I'm giving you 100 rupees. And after 10 years, what is the value of this 100 rupees? Like with 100 rupees, you are able to buy some product today. Say for example, with 100 rupees, you are buying some 2 kgs of rice today. Okay. After 10 years, with this 100 rupees, how much kg of rice you will be able to buy?
Maybe half kg, sir.
You can buy maybe half kg or 1 kg of rice, right? So that means what? The value of 100 rupees is now, after 10 years, the value of 100 rupees is
Reduced, sir.
reduced. Okay, but for this case, for this example, or for this assumption, like the first assumption what we're making is, the value of money does not change with time. That is, if I'm maintaining, if I'm giving 100 rupees today, and what the value of 100 rupees after 10 years or n number of years is going to be the same. Like 100 rupees is 100 rupees whenever you buy. So the value of money has not changed. That is one assumption I'm making here. Okay. So, so that is what I'm saying. Say, for example, if I'm giving you 100 rupees today, after 6 years also, the value of 100 rupees is 100 rupees only. Like that, we are making assumption, but in practical, that is not correct. Correct? In practical, that is not correct. After 6 years, the value of 100 rupees will not be 100 rupees. It can be, the value is, I mean, the 100 rupees is 100 rupees, but the value is less, right? So next you have to make a note of this formula, which says that uh, if you're planning to replacement, okay, the cost of the piece of equipment over a given period of say n years has 3 elements. Say, for example, you should first consider, when you're planning for replacement, you should first consider this: what is the purchase price? Purchase price is what? For how much you bought the machine, minus, okay, value remaining after n years. After n years, what is the value of this product, plus maintenance cost for n years. Say, for example, you are buying a bike. Okay, let's assume you are buying a normal scooter. What is the average cost of a scooter now in the market? Hmm? What is the average cost of a bike in the market now?
1 lakh, sir.
1 lakh. Then after, what is the value of the bike after 10 years?
We will reduce around 50%, sir.
15%, huh?
Yes, sir. 20-30% we will reduce, sir.
Okay, then how much will be the cost?
From 80,000 to 70,000, sir.
After 10 years?
After 10 years, 50% reduce, sir, to 14,000 like that.
You can sell your bike only for 10,000 or 14,000 only. You bought a bike for 1 lakh rupees, because after 15 years you have to go for everything. So let's assume 10 years, and if you assume the depreciation rate of 10%, for 1 year, if you assume the depreciation rate is 10%, after 10 years you can't even sell the bike. You got to give the bike for free only. Okay, so what is the value remaining after n years is very important. Plus maintenance cost for n years. For every year, how much you spent on maintenance. First year you will spend only 1,000 rupees. Second year you're going to spend 5,000 rupees. Third year you're going to spend around some 8,000 rupees. Like that, the maintenance cost will also keep on increasing when you are want to sell the product, right? Or the maintenance cost will be increasing as the years increases. The value of the product will deteriorate or come down from the purchase value. Whatever, I mean, depending upon the years, the value will come down. So, say, for example, you're buying a apartment, or you're buying a house for some 60 lakhs or 1 crore rupees. Okay, after 10 years you can't sell the house for the same 1 crore rupees. Why? Because there is a depreciation value for the house. Same with the bikes or cars or something. So the purchase value can be 1 lakh or 1 crore. The selling value will be 10,000, or if it's a house, it is going to 1 crore house, it's going to be around like some 20 lakhs, 30 lakhs after 10-15 years. Okay. Then plus every year you're spending some maintenance on the house, or every year you're spending some maintenance on the bike or the car. So that is why the maintenance cost will be increasing. The value remaining cost will be decreasing. Purchasing cost will be constant. Okay, so this is the formula which you should understand. Okay, so the same thing I'm writing it as this formula. So please make a note of this. Please make a note of this formula for replacement policy. Okay, here C is the purchase cost, purchase price, like for how much you bought the component. Then what is the scrap value? That is, after n number of years, what is the scrap value? Plus, what is that maintenance cost you spend every year? That is why all maintenance costs I'm summing up and writing. Okay, so what I'm doing, so every maintenance cost, I'm trying to copy and write. Like I'm going to sum it up. Okay, so please make a note of this formula, because using this formula, we'll be solving the problems. Okay, so now then we have to find the average cost. After calculating the total cost, we have to calculate the average cost. What is average cost? If I divide this total cost by the n number of years, okay, the average cost, like for every year, if I'm calculating the average cost, and that is called as, that is how we will calculate, divided by the number of year, 1 by n. And when this an value or the average cost value is less, that is the correct time for you to go for replacement. Okay, so please note down this formula as well. Total cost divided by n will give you average cost. Have you noted down these two formulas? Noted?
Yes, sir.
Okay, thank you. Next, so this is the formula, this is the problem which we are going to solve. Here what I'm saying, a firm is using a machine whose parameters price, or sorry, this should be purchase price. Okay, this is purchase price. Okay, this 13,000. Okay, you are buying a fridge, for example, you are buying a fridge for 13,000 rupees. The installation charge is around 3,600. Okay, the installation charge is how much? 3,600. Okay, now tell me, what is the cost of this machine? You got my question? You're purchasing the machine for, you were purchasing a washing machine or a fridge for 13,000 rupees. The installation charge is 3,600. Now, what is the cost of this machine? Sir, I want to fix 16,600. That is the total
Yes.
cost of the machine, correct? You should include the installation charges also. Okay. Next, if I'm selling the scrap, if I'm selling the machine, or if I'm scrapping it down after using for a certain time, if I want to give away the machine, they'll buy only for how much? The scrap value is how much? So
1,600, sir.
So this is C, this is your yes, 1,600. Because the family, okay, the maintenance cost in years. So the first year you're spending 2,050 rupees as maintenance. Second year you're spending 750. Third year 1,000, 1,500, 2,100, 2,900, 4,000, 4,800, 6,000. So you're using the machine for, this machine is used for 9 years, and every year you're spending some amount as maintenance cost. Okay, now what they're doing, they want to know in which year it is better to replace the machine than spending on maintenance. So imagine, I told you the cost of the machine is 16,600. Okay, the cost of the machine is 16,600, and they're asking me when to replace, because in the ninth year you spend around 6,000. The eighth year you spend 4,800. Seventh year I spent 4,000. So I think if you calculate the maintenance cost for this machine, it is more than the original cost of the machine, correct? If you sum up the maintenance cost of the machine, it is more than the original cost of the machine, correct?
Yes, sir.
Okay. So now we should find what is the right time, or when we have to go for replacement of this machine. So as I told you, the cost of the machine is what? Installation charges plus the cost of the purchase price plus the installation cost. So 16,600. Scrap value is 1,600. It is given in the problem. So now you can make a table like this. The machine is used for 9 years. The machine is used for 9 years. The maintenance cost is given in the problem. Same I have written here. One is years. Maintenance cost is here. Okay. Now I have to find the cumulative maintenance cost. So cumulative maintenance cost is 250 plus 700 plus 1000 plus 1000, 2000 plus 1500, 3500 plus 1100, 5600 plus 2900 plus 4000. Okay, so like this you keep adding. Okay, so now you know how to calculate the cumulative maintenance cost, the third column. Are you able to understand this step?
Yes, sir.
Okay, now what I have to do, I have to calculate C minus S. What is the value of C? 16,600. What is the scrap value? 16,000. Sorry, 1,600. So 16,600 minus 1,600 is how much? How much?
15,000, sir.
15,000. So that is what I have written here. Okay. So now I have to calculate Tn. The formula to calculate Tn is C minus S plus summation of maintenance cost. Correct? From this formula. Okay. Same formula I'm using here. So Tn is equal to C minus S. C minus S is this value plus summation of maintenance cost. So this two I'm adding. So it is going to be 15,000 for the first for this alone I'm telling 15,000 plus 250. How much? It's going to be 15,250. Okay, are you able to understand how we got this value? You are adding this two and giving it here. So next case 15,000 plus 1,000, 16,000. Like this you are adding and giving the third one. Okay, so now we'll see how to calculate AN. What is AN? AN is the average cost. How to calculate the average cost? Okay, so how to calculate the average cost? What is the formula to calculate the average cost? Average cost is AN is equal to TN divided by N. Okay, N is the respective year. So that's why I written N is the respective year. Say for example, what is the first? How to get this? It's 15,250 divided by what is the N now? For the first column, first cell, sorry, the last column, first cell, what is the N value? N is the year. What is the year now?
One only, sir.
One only. So that's why we got this. Second case, this one. 16,000. Okay, 16,000 divided by
2, sir.
what's the 2? So you have to use the respective year. For which year you are calculating, for that N only you have to use. So now 17,000 divided by 3. 17,000 divided by 3 will give you, so this is divided by 1, this is divided by 2, this is divided by 3, this is divided by 4, by 5, by 6, by 7, by 8, by 9 will give you this answer. Okay. So now, as we already told you, the optimum, okay, the optimum replacement period would be the one corresponding to which AN would be minimum. So when the AN value is very less, that is the right time for us to replace the machine or the equipment. Are you able to understand? So that's why what we did is, in this case, which is the lowest value? In this column, which is the lowest value?
6th year, sir.
6th year. So what you should advise is, this is the right time, that is the 6th year is the right time for us to replace the machine. This is till this, it is the right time. Okay, after this time, after the 6th year, whatever, again the maintenance cost is going to keep on increasing. So that is why it is more advisable for us to replace the machine in its 6th year, or at the end of the 6th year, the machine has to be completely replaced. So that is how you calculate. But in this case, what we are assuming that the cost of the product is the, I mean, the money value is same. Okay, that is one assumption we are making it. Okay, are you able to understand this problem? Whether it is easy?
Yes, sir.
Okay. The same problem is given to you in the same kind of problem is given to you in the digital assignment number 2. Okay, so that's why it's very important. Okay, good. So that is how you find the replacement year. Okay. Now this is the second case. Now we are going to interpret this question for me. There's a company called as the Simplex Engineering Company who produces a machine. Okay, who are producing a machine whose purchase price is 80,000. Purchase price is 80,000 means what is this value?
C
What
is
is
equal
this?
to 80,000.
Very good. So C is equal to this one. So C value is given. The expected maintenance cost and resale price in different years are given under this. After what time interval, in your opinion, should the machine be replaced? So this is maintenance cost. Maintenance cost with respect to the years it is given. What is resale value? What is resale value? How you represent resale value or the scrap value?
So year wise they are given, sir. 75, 72.
Okay, okay. What is that? C is given, MT is given. What is this?
Yes, sir.
Yes. In the last example, S was constant because it's a monopoly business, they told. But here, what is this? 75? 75?
Resale, sir. Resale value.
What is this? No, no, no. What is that? Resale value in what rupees? No, 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 no. Translate. Okay. So what is this resale value? How much it is? 75?
Rupees, sir.
No, no, no. What is 75 rupees? What is, how much is this? 75? Read that problem. Resale 30 rupees. What does that means?
Okay. 75,000, sir.
75,000, 72,000, 70,000, 65,000, 58,000, 50,000, 45,000. Okay. So this is very important. Please note this. Without this, if you are doing the problem, you will end up making mistake. So read the problem carefully. Okay. Now we are going to solve this. Same problem, the same values. I am here, it is given in row wise. I'm making it into column wise. So this is done. This is done. So we know first we have to find the cumulative maintenance. You know how to find the cumulative maintenance?
Yes, sir.
Okay, so you have done this. Okay. Next you have to find the C minus S. C value is given in the problem as 80,000. Okay, you know 80,000. It is given in the problem here 80,000. S value is given here, but in how much? How much is S value for the first example? 75?
1000, sir.
75. The second year, 72,000. Like that, it goes. It is in thousands, not 75, 72. Don't get confused and make a mistake. So 80,000. What is this? What is this? 80,000 minus 80,000 minus
75,
75.
75,000, sir.
75,000. What is the answer? From 80,000, if you separate 75,000,
5,000, sir.
5,000. Okay. Then from 80,000, you have to subtract 72,000. How much?
8,000, sir.
8,000. So like that, you're doing here. So for the respective years, you're minus subtracting the scrap value or the what do you call resale price. Okay. Now we know this formula again. T power n is equal to C minus S plus summation of MT with the respective years. So C minus S value is given for the first case 5,000 plus what is the cumulative maintenance?
1,000,
1,000.
sir.
How much is? So you get 6,000, right? For the second case, 8,000 plus 2,200 will get 10,000. Like this, you are going to calculate. That is this plus this. Will give you this. Okay. Now, how to calculate AN? AN is formula we know. AN is equal to TN divided by the respective year. First case 6,000 divided by
1, sir.
second case divided by 2, 3, 4, 5, 6, 7. So you're going to get this. So out of this, which one you have to select in order to know which period you have to subtract? Why? And tell me why you have to go with that. Out of this, which is the less value? Out of this
Third year, sir.
third year, the value of average cost is 4,600. So wherever you get whenever you find that the average cost is very low, that is the right time for you to replace the machines. Okay, so in this machine, for this machine, which is the right year, I mean, after how many years you are going to replace the machine?
After 3 years, sir.
Huh?
After 3 years, sir.
After 3 years, you have to go for replacing the machines, because you can see the average cost is decreasing here. But after third year, it is increasing. It's increasing. It's here. It is increasing. So if it keep on increasing, so that time it is not advisable for us to. That means what, you're spending more than the cost of the machine, right? So that is why that is not advisable. So that is how we should do the replacement problem. So far what we assumed is, we assumed that the money value is constant. It is not at all changing. The value of 100 rupees is same as the value after 100 years. But in reality, you know that is not true. So now we are going to do the same problem, assuming that the time value of money is considered. The time value of money is considered. That is, as I told you, if I give you 100 rupees, you are going to buy 2 kg of rice today. But after 10 years, you told me that you can't buy with 100 rupees, you can't buy 2 kg of rice. You told me you can buy only 1 kg or half kg of rice because of the money value inflation, right? Okay. If that is the case, what I'm trying to do is, then how will you do? So like if you know this interest rate and other things, you can answer this, right? So if the rate of interest is R, the present value of money would be after 1 year is 1 divided by, if you're giving 1 rupee, after 1 year it is 1 plus 1 divided by 1 plus R. 1 plus R is what? The interest rate. 1 divided by what is the interest rate? So that will be gain. So for n, after n years, so this will be the formula. Okay, so then what is a compound interest formula? A is equal to P plus 1 P into 1 plus R power n. So this formula you memorize. You have to know this formula. That is compound interest formula only. Compound interest formula to determine the amount A is equal to present value into 1 plus R power n. R is the interest rate. N is the number of years. P is the present amount. A is the compound interest or amount A. Okay. If A is equal to 1 rupee, P is equal to 1 divided by R plus 1 plus R power n. Okay. So you just understand this. Like if I'm giving you 10 rupees, okay, what is value after 100 rupees? If I'm giving 100 rupees, what is the value after 10 years is 100 into 1 plus, if the interest rate is 0.2% or 0.5%, 1 plus 0.5 in power n. N is 10 years. So that is how you have to calculate the money value after 10 years. Okay. So now we are having something important to understand. If I give you this problem, you should understand one thing, that is present value. So this present value of 1 rupee is 1 rupee only. But after 10 years, what is the present value of 1 rupee? Do you remember we used something called as 5 paise, 10 paise, 25 paise, 50 paise? You remember that?
Yes, sir.
You can buy a chocolate with 25 paise. And my father was telling that he was even using 1 paise. 1 paise, less than 1 paise, less than 1 also they were using. Right? But nowadays we don't have that. If we tell that if you give 5 paise and ask for a chocolate, they won't give you. 25 paise is no more. Okay. So that's what the present value of money will not be the same in the future. We know that, but how to calculate that, right? So then what we are trying to do, we are assuming something called as PV factor. PV factor is nothing but your present value factor. Okay. So there is a table where they'll give you, there's a standard table from where you can get the present value factor. That is, if you are having 100 rupees today, what is the value after 10 years for this 100 rupees is, you have to multiply that 100 with the present value factor. Are you able to understand? If you want to know, that is, I'm giving it again. If you want to know how much is 100 rupees after, what is the value of 100 rupees after 10 years, you have to multiply that 100 in with the present value factor. This present value factor will be provided by Reserve Bank of India or the country where you are. So the present value table is different from country to country. This present value factor is like a log tables what you have to do. So there is some standard value which you have to multiply with your amount. Okay. So now okay. So then, but in this case, we are assuming that we are assuming two things. That is, first assumption is equipment in question has no salvage value. What is salvage value or resale value or scrap value? We assume that the equipment has no salvage value. Second assumption is every year you are spending the maintenance cost at the starting of the year. Okay, say if April is the starting year for companies, for financial organizations, April 1st is the starting date. That means with April 1, that is day after tomorrow, you're going to open it tomorrow, right? Day after tomorrow, you're going to open a new account book. So that is, you're going to do the maintenance activity in the April month itself. So that is when the year begins, you're going to do the maintenance. If you're in the year beginning, if you're doing the maintenance, means what? You will spend all your maintenance cost in the first month of the financial year itself. So that is why we are assuming, in this case, we are assuming maintenance costs are incurred in the beginning of different time periods in years. Like beginning year, when the year starts, you're spending on maintenance. You're not spending on the middle or the end of the year. When the year starts only, you're spending your money on maintenance. Just like a few of us, right? Whenever the year opens, immediately we go to the gym and pay the money. with your new resolution to reduce your body weight and be fit, we join the gym in the year starting only. But after that, what we do? We don't even go to the gym. After 2 weeks, we don't even go to the gym, right? So that is what we are doing. So here also we are assuming that every year starting only we are doing the maintenance activity of the machine. Okay. Now this is the formula. This is the question what we have. So this question is telling that there's a machine X. The cost of the machine is how much? Please read this question and read along with me. The machine X cost is
5,000, sir.
5,000 rupees. Okay. So that is that value is what you call? That value is called as the
C.
C. This is your C value. Okay. Now what is the question is telling? Read the next part. Its maintenance cost is 1,000 in each of the first 4 years. Normally they used to give them give a tabular column and tell you what is the maintenance cost per year in the last problem. But in this problem, they're telling for the first 4 years, what is the maintenance cost?
1,000, sir.
For the first 4 years, the cost is 1,000 rupees, and then it is increased by 200 every year. So first 4 years, the maintenance cost is 1,000. For the first 4 years, the maintenance cost is 1,000. What is the maintenance cost in the 5th year then? By reading the problem, what is your understanding?
3,000, sir.
3,000.
Increasing every.
Sir, first 4 years, the maintenance cost is 1,000, sir. What in the 4th year, first 4 years, 1,000 rupees you are paying. 1,000 rupees, 1,000 rupees, 1,000 rupees, 1,000 rupees you are paying. Every year you are paying only 1,000 rupees. In the 5th year onwards, they are telling that it increases 200 per year. 1 year is spending 1,000 rupees. Next year, 4 year till 4 years, you are spending only 1,000 rupees. How much you will spend on the 5th year? 1,000?
1,200, sir.
Very good. 1,200. Every year you are increasing by 1,200. In the 6th year, how much you will be paying?
Need time, sir.
1,000? You'll pay 1,000 rupees, or you'll pay 1,200, or you'll pay 1,400.
1,400, sir.
You'll be paying 1,400. Okay. So first 4 years 1,000 rupees, 5th year 1,200, 6th year 1,400. Like this, you'll be keep on adding. You have 200 rupees. After 5th year, you're going to add. After 4th year, you're going to add 200, 200, 200 like that. Okay. So anyone is waiting in the lobby? Ma'am, you can use the link, no? Why every time you are doing like this? Every day, every week you are doing the same thing. After 1 hour, you want to join. Okay, so what I was discussing, we're discussing that the maintenance cost for the first 4 years is 1,000 rupees. From the 5th year onwards, you have to add 200. 6th year again, you have to add 200. That is 1,200 will become 1,400. 1,400 will become 1,600. 600 will become 800. 800 will become 2,000. 2,000, 2,200. 2,400. Like that, it will keep on increasing. Okay, now they're asking me if the machine has no salvage value and the maintenance cost is incurred in the beginning of the year. That is the assumptions you have to make, right? Determine the optimal replacement time for the machine, assuming that the time value of money is 10% per year. Every year, the depreciation value is, that is the money value is that what do you call the PV factor value is 10%. 10%. Okay. PV present value factor is 10%. Okay. Now we know this. Okay. So now what I'm doing now, I'm interpreting that years. I made some 12 years. Here I made some 12 years. Okay, the maintenance cost for the first 4 years, for the first 4 years is how much? What was given in the problem? For the first 4 years, it is maintenance cost is am I audible? What is given here? For the first 4 years, what is the maintenance cost?
1,000, sir.
Tell me now, then why you are keeping quiet? Only one person is answering my questions. Rest others are become dumb or what? So the first 4 years, the maintenance cost is 1,000 rupees. Then they told that every year it increases by 200. So that is why in the 5th year it has become 1,200. Then again 200 added, 1,400. Again 200 added, 1,600. Like this, you keep on adding the 200 rupees. You keep on adding for the 12 years. Then they told that 10% is your 10% is your PV factor value. So 10% of 1 rupee will become this one. So you multiply with 10%, 10%, 10, 10, 10, 10, 10. You can calculate this. Then we have to calculate P value of MT. So present, what you have to do, you have to multiply this maintenance cost with the present value. If you multiply this and this and this, you will get this values. Okay, you are going to get this. Then again, we are going to go back to the regular thing. Now you have to again find the cumulative cost. Cost plus cumulative MT. Cumulative MT, how to find out from this? Okay, that is cumulative MT plus cost. Now this becomes the this one. What is the cost of this machine? It is given as 5,000 rupees. So 5,000, because C value is 5,000 plus 1,000. MT value is 1,000 for the first year. It will give 6,000. For the second year, it becomes 5,000. You have to make cumulative, right? You have to make cumulative. So this plus the present value, this plus this plus this plus this plus. Like this, you have to calculate. So this plus this, this plus this. Like that you have to make. Then again, you have to make the cumulative of the PV factor. That is, cumulative of PV factor is this one. This you're writing here. Then you're adding with this, you're adding this. You're adding with this and you're getting this. You're adding with this and you're getting this. You're adding with this and you're getting this. Like this, you're doing for the entire thing. Then you have to find the annual cost. The annual cost is what? AN, TN by, now you got the TN value. This divided by the cumulative factor. So 6,000 divided by this, 6,909 divided by 10. Okay, so this divided by this divided by this will give you this. 7,000 divided by 2,000, 2.3 will give this. 8,000 divided by this will give this. So like this, you have to find. So once you find this, after a certain point, what will happen is you are going to find what is the lowest value in the annualized cost or the average cost, AN. Okay, what is the lowest among this? The lowest among this is 2,042. So that means what? This is the right time for us to go for replacing the machine. In this case, we have assumed PV factor or the present value factor, because we assume that we go with the truth that the money value will keep on changing as you pass the years. So that is how you should do this problem. Okay, fine. Next, but there are certain cases where we have to go for group replacement. Okay, see, because what happens? Yeah.
So how you take the 12 years only, sir? In question, they are not mentioned up to 12 years and also.
You can add how much hour year you want. Okay. You can add as much as you want, no problem. But this is how you have to do the problem.
Sure, sir.
Okay.
Okay, sir.
Okay. So next is like what happens when what is the replacement strategy for equipment or items which fail suddenly? Okay, so in this condition, what happens is you have to find an optimal replacement policy for your product when all your components are going to fail suddenly. So what happens is, in sometimes your equipment will not function because of one unit which is getting failed, and it is not cost effective for you to replace that one. It's better to go for replacing the entire unit. Okay, so entire unit or entire subcomponent. So that is when it is going to be beneficial. In some cases, it's not always true, but in some cases, rather repairing that one particular item, it is better beneficial for us to go for replacing the entire unit itself. So that is when we go for group replacement. Okay, this group replacement is done in short intervals, and obviously this is going to be more costlier. Okay, it is going to be costlier to replace, but rather repairing one by one, it is sometimes more advantage for us to do the group replacement, so that the cost of replacing one item is more costlier. If you keep on replacing one by one, it is going to cost you more. So rather you can go for replacing the entire unit itself, which is more cost effective. So that's why we go for group replacement. That is, it is sometimes it is more advantage for us to replace the sometimes companies do this, right? Say for example, there are 10 workers. Okay, and every time whenever they have to they will see the efficiency of this 10 workers, and if some workers efficiency is not good, what they will do, they'll fire them, right? They are going to fire them. But when recruiting, they may and if they have to fire one by one, and recruit one by one to refill the or to replace the employees. But sometimes what will they is, they'll go for bulk recruitment of 10 people, and they will completely remove all these 10 employees and put the 10 new employees. Why? Because it is very good to do the group replacement than removing one by one and replacing with one by one. So that is what is called as group replacement policy. Okay, because actual pronouns will determine the optimal, but what is optimal interval time? Then when should we go for this group replacement? Okay, so in this case, we know we are plotting a graph between cost per unit time divided by group replacement interval. So here it represents the sum of cost of group replacement time, cost of group replacement per unit of time, and the cost of individual replacement of items which fails during the replacement. So this is obviously, it will be like this, right? So if you keep on replacing this, okay, if you keep on replacing this, what is the cost? Okay, so initially your component will be running for some time. That second replacement will happen here, third replacement can happen here. So what happens is, like, when you go keep on replacing, the time interval for replacement is coming down. The time of implementation will be coming down. But when do a group replacement, it goes like this. So if you want to find the optimal time, so this is the right time, that is the space where the intersection happens. That is the optimal time for us to go for replacement. Okay, so that's why we should suggest group replacement when the right boundary is struck. Okay. Okay, so with that we are completing the replacement. Okay, now let's move on to the next topic. This is a part of your topic which you are going to cover in the upcoming modules, but let's see the fundamentals of reliability centered maintenance. Okay, the word reliability centered maintenance, reliability we have studied, sir. Maintenance we have studied. So far we are discussing about maintenance and its types. In the last class we discussed completely about what is maintenance and what are the maintenance types. We discussed in the first two models, we discussed a lot about reliability. Now I'm saying you something else, reliability centered maintenance. Okay, that is uh, maintenance is carried out based upon the reliability, and this reliability centered maintenance is applicable and effective when you are practicing preventive maintenance strategy. So wherever I'm using PM from this model, hereafter it means preventive maintenance. Okay, when you will do preventive maintenance, when you will do preventive maintenance, When will you do preventive maintenance?
Monthly once, sir.
Sir, what is preventive maintenance? I'm not asking when you will do. I'm asking you when you will go for preventive maintenance. What is preventive maintenance? The last class we discussed. So tell me, what is preventive maintenance? What is preventive maintenance? Last class we discussed, right? Super.
So
Okay,
regular maintenance activities, sir.
Sir, preventive maintenance activities are the activities which you do well before the maintenance, sorry, well before the failure is going to happen. Okay, so
Yes,
that
sir.
means whatever you're doing, whatever actions you're taking as part of your maintenance activity, whatever activities you're doing before the failure has happened, that is proactive. Before run to failure is reactive model. Preventive maintenance is a type of proactive maintenance. That is, before something is happening, you're taking a vaccination. Before your fever, you're taking a shots for injection for preventing the fever. So all these activities, whatever you do for your body, or whatever you're doing for machines to prevent the failure from happening, we call that as preventive maintenance. That is what we discussed in the last class. Okay, so that is preventive maintenance. So this, if you are carrying out this preventive maintenance, in the last class we discussed about this preventive maintenance, we also do based upon the data or the information what we collect from the machines, from depending upon the behavior of the machines, depending upon the now I even spoke about how these windmills are working, how the tribology between the gears and the coolant oil is maintained, how do they carry out the maintenance activity of a windmill. That time also discussed about this. So this reliability centered maintenance is runs with the lot of information or the data what is collected from the machines. Using the data, or we do the reliability calculations, and we come to a conclusion that this is the right time to do the preventive maintenance in this machine. Okay, that's why we call that as a reliability centered maintenance, because preventive maintenance is what we are doing the maintenance activity before the machine is failing. And how or when to do this preventive maintenance is decided by the data what is collected from by the machine. What data we are collecting? We are collecting the reliability data. To do the reliability calculations, we are doing the that is failure rate you are predicting, and we using the failure rate and other mean time between failure, everything you're computing, and with that you are able to come to a conclusion that with the reliability data we are able to come to a conclusion that this is the right time for us to do the preventive maintenance, so that the machine will not fail after this time. So that is what we call as reliability centered maintenance. It was originally developed in 1960 by the US Air Transport Department. Then their Defense Department adopted it. Later, they even implemented in their nuclear program. Okay, so that is the highlight of this reliability centered maintenance. In reliability centered maintenance, the main objective is to obtain optimum level of performance from any physical asset at minimum life cycle cost. That is, with minimum period, how much work you are able to extract from that. Say for example, some components cannot function for a long time, but in that working life, how much you are able to, how much job you are able to, how much work you are able to extract from that particular component. Okay, say for example, in a home you may have a mixie or a laptop or a mobile phone. Some people will tell that I'm not using my mobile phone for, I'm using my mobile phone only for, or my TV for only 2 hours a day. And this, what happens after 10 years? Okay, after 10 years, the number of hours of usage of this TV, say for example,
என்ன பட்டு அது டாடா கேபிட்டல்
please
பேசுறியா?
put yourself on mute. Okay, so if you have any questions, unmute and ask. Otherwise, keep your mics on mute, please. Okay, so what happens is that you're using a compound is there, it is running for 1 year. Let's assume you have a machine or a component, you are running that for for 1 year. Some people will, in 1 year, they can use the mobile phone for somewhere around like 1,000 hours they will use. Some people will use their mobile phone only for 100 hours per year. If you open your phone, you can check what is the average average time, how much you're spending on your mobile. Okay, if you could find that, some people will have, on an average, they will use, out of 24 hours, they will use their mobile phone for 24 hours or 23 hours they'll be using. Some people will be using only their mobile phones only for 1 hour or 2 hours. So now, who has used the mobile phone more effectively? The person who is using the mobile phone for 24 hours or 23 hours has used that mobile phone for effectively. Let's assume that mobile phone works for only for 1 year. Both the cases, the mobile phone is going to work for only 1 year. One person is using the mobile phone for 23 hours a day. One person is using the next person is using the mobile phone for 3 hours a day. Who the person A is used for 23 hours. Person B is using the mobile phone for 3 hours for 1 year. Who has used the mobile phone more effectively? Person A or B? My answer is, I know you. Luckily, you answered. Okay, so we know that the person A has used his mobile phone for a longer time, and he has taken a completely has used it, because he knows that anyway the life of the mobile phone is going to be only 1 year. So let me use it the most possible. So he is using the mobile phone continuously, and because he's more addicted to the mobile phone, so his screen time is 23 hours. Whereas the other person is not even using the mobile phone, is using only for 3 hours a day. So he is not using that much for in 1 year. So, but even though he is not using that much, the machine is going to fail. So what we have to do, we have to do some maintenance activities to. And what this person A will do, he will continuously charge the mobile, maintain the mobile properly, so that he can keep using the mobile phone for a very longer time, which is not possible. The second person is not doing that. So his mobile phone will last for 1 year, but he's not has used the mobile phone to the fullest potential. Right, so that's why this reliability centered maintenance will help us to understand when this machine is going to fail based upon its performance, and when to carry out the maintenance activity continuously, preventive maintenance activities continuously. And when you do this preventive maintenance activities continuously, what will happen? The availability of the machine will be more. When the availability of the machine is more, as we discussed in the last class, when the availability is more, that means what? The machine is ready to perform its function correctly at any given time. If you're doing a preventive maintenance, the next advantage is the machine is more capable enough to produce a very good quality product. When your quality of the product is good and the machine is available all time, automatically that means what? The efficiency of the machine is very good. When the efficiency, quality, and performance of the machine is all good, automatically the components produced by the machine is going to be of good quality, and the quality component they are producing, it will end up in making profit for the company. That is why, again, I'm coming back to this level, that stating that reliability centered maintenance is very good. Because in using reliability centered maintenance, I'm able to maintain the machines very do the proactive preventive maintenance. Preventive maintenance is one type. So preventive maintenance I'm able to do regularly based upon the reliability data what I have, and I can run the machine for a longer time, and I can extract more work because the machines are more efficient and perform well. I can extract more work from this machine. That's why reliability centered that is going to be the objective of this reliability centered maintenance. Okay, how to do this this reliability centered maintenance? The methodology is simple. First, you should understand step by step. Okay, this is a logical step by step consideration. It has some 6-7 steps. You will understand this. First is what? Function of a system or a component. First, try to understand what the component is designed, and and how much this how this system should function. What is the functionality of this component, or what is functionality of this machine? Try to understand for what it has been designed. Try to understand that. Next you have to do the methods of failure of that function. Okay, my machine is designed to grind a sample or grind a workpiece. If grinding is the function of that machine, for what reasons the grinding process can be affected, or for what methods of failure can happen, for how the grinding machine can fail? Try to understand. Then importance of the function and its failure. Then we should understand this, what is the role of this grinding machine in my company, and if this grinding machine is failing, what is the impact it is going to create on the subsequent processes. That you should understand. Next, a priority based consideration that identify those preventive maintenance activities and that both reduces failure potential and are cost effective. First case, what you did, you studied your product and understood what it is functioning. Say for example, in our case, I'm told you have a machine that is going to do grinding. Next, methods of failure of that function. So how the grinding process can fail, that you're studying. Third, importance of function and its failure. That is, because of what reasons the grinding process can fail. In the second step, you're identifying, and you're trying to understand, if this machine, this grinding machine is failing in my company, what is the subsequent, that is, what is the other process that are being, that what is the impact it is going to create to the company or the process, how my production is going to be affected because of this, that you're trying to study. Okay, now we know what damage it is going to create. What you can do, you can be prepared to do the maintenance activity. Okay, you know, grinding machine, what is the type of failures that can happen in a grinding machine. So now if you're an expert, what you will do, you will understand the reasons for failure, reasons for this grinding process to fail. You will have the possible solutions with you. What are the preventive maintenance activities I should do to prevent the failure of this grinding machine? You will study, and at the same time you will look for a cost effective solution, right? That is what we could do in the reliability centered maintenance. So that's why this will help you to do the maintenance activity well in advance, but at the same time you will also have the option of doing it in a very cost effective manner. Okay, so next, how now let's discuss one by one how it is carried out, step by step procedure. First is different definition of system boundaries. System boundary, for any problem to solve it mathematically, we will be fixing the system boundary like this. What is my level of exposure, or what is my level, what is the level I should focus? That is system boundary. Means in this case, it is going to be the boundary what I'm going to set. Like my I'm going to examine only the grinding process, or I'm going to study only the grinding process plus the drilling process. So if this is the two things you're going to study, or either one thing you're going to study, that is the boundary what you're setting down. Okay, that is something like I will work only on this particular assembly line. I'll work only on this particular machine. Like this, you're fixing a boundary. Next is determination of functions of a system and its subsystems or components. Then you should know how this particular after fixing the boundary. Say for example, in our case, I'm going to fix the boundary only to the grinding machine. So now I'm going to study how this grinding machine is functioning, and I'm going to study what is the internal components of this machine and how each and every component inside this drilling inside this grinding machine can fail. Like this, I'm going to study I'm going to break down this grinding machine into different parts, and I'm going to study. Breakdown means like not physically breaking down. I'm assuming, okay, like part by part, I'm studying what are the reasons for which this this machine can fail. Like that, I'm trying to make a sum up. Then I'm going to study determination of function failure. Okay, so a functional failure occurs when a system or system fails to provide the required function. Like what? So functional failure is for each and every component. Say for example, in a grinding machine, we may have a motor. For what are the reasons the motor can fail? And there may be some rotating components. What are the reasons for this gears can fail? Like this, functional failures for each and every unit component. I'm trying to find out the functional failures or the reasons for failure of this component. That I'm trying to do. Okay. Next case is determination of dominant failure models. Like there may be some 4 or 5 reasons for the motor in a grinding machine to fail, and I'm trying to list down the causes for failure of this motor, and among these causes, which is the most predominant one, or what you call the most dangerous one. So out of all failures, what is the most dangerous failure, or what is the prime major reason for the motor to fail? That I'm trying to find out in the dominant failure stages. Then for that particular failure, you can also use FMEA, failure mode effective analysis, to do this activity. Okay, you can have a Ishikawa fishbone diagram or something like that. You can do or to do this failure, study the failures, and to come out with the FMEA chart, FMEA chart. Next, what you're going to do, you're going to determine the correction actions. What are the correction actions I can take? What are the preventive maintenance task I should do to ensure that that motor of the grinding machine is not at all failing? So coming out with this, then integration of results. Now, at the same time, when you're proposing the corrective actions, you should also come out with the with cost effective, which will also ensure that the failures will not happen in the future. That you should ensure. Then integration of results. You should now after doing everything, you should draft a plan, or you should draft a protocol which will ensure, which will give the details of how to maintain the machines and how much periodically you should do this preventive maintenance activity. Those things you should come out. That is what we discuss in the reliability centered maintenance. Okay, now how to implementing reliability centered maintenance. So how to implement? First, you call your supervisors, operators, your craftsmen, your specialists, and you form the RCM review groups. Then you determine, or what you call as then the individual you call as the RCM facilitator. You assign roles. What is the role of the supervisor? What is the role of the operator? What is the role of the craftsman? And other people in this team? What is their role? Define their role. Then implementation strategies. You should implement RCM very quickly, but at a cheaper price, and it should be and non-participating versus, like, some people will always look for cheap, quick, and they will not be participating. So but rather it should be slower. It should not be quick, cheap, and non-participative. It should be slower process. It should be resource intensive and participative. So we should choose which one you have to go. You can use a quick, cheap, and non-participative team, or you can go for a slower, resource intensive and participative team. You have to decide which one to choose. Then what is the significance of equipment and level of analysis? This you should make them to understand. Then how to get started. So you have to come out with a plan, how to get started, how to form it, how to inform your employees about this to start this process. Okay, but what are the advantages? Advantages is it is a very RCM is a very slow process. It will take some time for you to study the machine, you study the problem, suggest the corrective actions, implement the corrective actions. It is going to be a very long time. Okay, it is used in power generation, manufacturing, plant maintenance, commercial aircraft production. Everywhere you will find this application of this RCM. Okay, now what is the overall benefit? You can have a better overall equipment effectiveness, or what you call as OEE, which we discussed in the previous class. Okay, here OEE formula is A into B into C, where A is the actual operating time divided by available time. Next, that is availability. B is actual standard production hours produced divided by theoretical standard production hours available. Sorry, B is availability. Then C is production, good production divided by total production. That is quality. Okay, performance into availability into quality. That is the formula to calculate OEE. Okay, you will have a question from this how to calculate OEE. Okay, next, OEEs are the equipment level, but for the plant, how to calculate the performance of the plant is the entire unit, right? It's A into E into Y. A is the availability, E is the efficiency, and Y is the yield. Like how much time the plant is available, what is the efficiency of the plant, what is the yield of, what is the production rate, yield or the production rate of this plant that you're going to maintain. So when you do this preventive maintenance based upon reliability, you can reduce the cost of the maintenance. You can improve you can have very good teamwork. Individuals will be motivated because they know what they're doing, so the individual will be motivated. The working environment will be more safety, and it will give good environmental protection, and we are going to have a very good database for this, right? So because reliability centered maintenance, so you're going to have a database for which the future any problem is that they can refer to this future problems and they can also solve it, right? So that's why they're maintaining a database for all these issues, what is sorted out in the company through reliability centered maintenance based upon preventive maintenance. Okay, but what is the disadvantage? It has more advantages but very few disadvantages. One is applications hurriedly carried out. Say some people try to carry out this very quickly. Sometimes unexperienced people will be there to do these reliability calculations, which will again end up making a mistake, and they will be focusing more on MTBF and MTR. Sometimes that is may not be necessary. So these are the disadvantages of RCM applications. Okay, next part what we are going to look into is called as the inventory control in maintenance. Okay, now first we studied about replacement policies. Second, we discussed about reliability centered maintenance. The third topic and the last topic for today's session is inventory control in maintenance. Okay, please try to understand this inventory control and maintenance, how they are trying to do this. Why inventory control is important in maintenance? Okay, because regular production activity is different, but maintenance activity is different. Sometimes we need some spare parts to do the maintenance activity, but there will not be sufficient tasks. So before that, and when you're doing maintenance, the production can be affected. Inventory control can take a toll when you're doing the maintenance activity. So that's why it's very important for us to calculate the inventory control in maintenance. How to do that? First, for that, we should know what is reorder level or economic order quantity. Okay, but before that, we should understand what is the optimum level of additional stock we should maintain. Additional stock, how much we should maintain, what is the order quantity, what is the reorder level based on lead time, what is the service level, what is the stock out cost information. This 5 parameters you should know. Then when you know this 5 parameters, you can go for fixed order quantity or periodic or review approach. Fixed order or periodic approach, you can choose between these two, anything. First, let's discuss about the fixed order quantity, or what you call as the queue system. Okay, in this queue system, I'm giving it in a very simple way. You try to understand. Economic order quantity is what? You should understand this. What is economic order quantity? Anyone knows what is economic order quantity?
No, sir.
Okay. Say, okay, in your house, you are buying groceries every month. Okay. Let's assume that you're buying groceries every month. Say, for example, per month you are buying some 20 kgs of rice for your house, or 10 kgs of rice for your house. When will you go for, and you're using this, and after 1 month or 1.5 months, your rice is getting over, and you're going to go for buying a new bag of rice. When you will know that you have to go for buying the rice again? When you will know you want to go for buying the rice again?
Before it's 20% remaining, sir.
Come again? Sorry.
Before ending, sir.
Before ending. Will you wait till you take out the last hand of rice, or you will go before that?
Before that only will go, sir.
Okay. Your mother or your wife should say that, or your roommate will say that, boss, the rice is going to over. Please go now, because we can cook only for the next 3 days or 2 days or 1 week. Next 1 week only the rice will be there. So tomorrow is Sunday, so better you go and buy rice tomorrow. Otherwise, after Wednesday, I should put you on fasting. Only if that is a threat level comes to you, you go for tomorrow. You're going Sunday, you'll go and buy your rice. True or not?
True, sir.
Okay. So that means what? You should know when to go for ordering. So that correct level is called as reorder level, or what we call as economic order quantity. In industries, how this is happening? They will know that this raw material will come for producing this many components. This raw material X can last for Y amount of time. Okay, I'll put it in simple words. You're having some raw material. Your inventory manager will know that this material can be used for this many shifts to produce this many components, and the supplier of this raw material takes 1 week or 15 days for him to supply the raw material, new batch of raw material to my company. What do you call this? We call that as a lead time. The time you place the purchase order to your supplier to the time it comes back to your store, we call that as lead time. If the lead time for supplying that required number of raw materials by your supplier to your store is 1 week, what your inventory manager will do is he will release the purchase order 1 week before only. Say for example, next Saturday you need to you need your raw material to be in your store. He will release the purchase order by today, so that it takes 7 days for or 1 week time for him to bring the raw material from his facility to your facility. So that is what we call as the lead time. Lead time is the number of time or number of hours taken for you to come to satisfy your purchase order. Okay, so if the lead time is 1 week, so if you need your raw material to be there for the next Saturday, what your purchase manager is doing is release the purchase order by today, because the lead time is 1 week. And they know that if I order on today, this Saturday, he will get the raw materials by the next Saturday. So how he is coming to a conclusion depends upon the lead time plus what is the stock that is left out. Okay, now going back to our old example, you told that you are going to buy rice for your home or for your hostel or for your room where you're staying now. So what you will do, you will calculate what is the quantity of, see, when you're preparing your grocery bill, how will you prepare? How will you decide how much quantity of rice you want to buy? First answer this question. Now you want to buy rice. Tomorrow you're going to buy rice for your home or room or hostel. How will you decide how much quantity of rice to be bought?
Number of quantity we used, sir.
Number
Depend on
of
that,
quantity, what you're going to use, what is your consumption level. Based upon that, you'll go for buying some X kg of rice. Okay. Again, you will also see that what is left out, correct? How much quantity of rice already you have. You'll do that. You'll check that, right? Yes or no?
yes, sir.
Okay. Now, what do you call this excess quantity of rice? What is already left out? What do you call this stock?
It is called
You call that
inventory,
as
sir.
inventory. Very good. So, say for example, you want your monthly consumption of rice is 10 kgs. For example, it's a very small family. You are consuming only 1 day rice, 1 time a day. So you're going to consume only 10 kg per month. Just for assumption. Okay, 10 kg per month is what you require. Already you have 2 kg of rice in your home as inventory. Now, how much kg of rice you'll buy for the next month? 10 kg is your requirement. 2 kg is already in inventory. How much you will buy?
8 kg, sir.
8 kg. 8 kg is the correct level what you have to buy. How you arrive at 8 kg?
Because inventory 2 kg we have, sir.
Inventory is 2 kg. So whenever you're going to purchase something, your purchase manager will subtract whatever inventory that is left out, what is required, he will know, and he will subtract what is already available in the inventory. So then only you'll go for making the purchase order for 8 kgs. And imagine you don't have any shops nearby your factory. So no supplier is near to your factory, or no supplier is there, no grocery shop near your home. You have to go to Hosur or Krishnagiri to buy the rice, and it takes minimum 15 days once only you can go to buy the rice. Okay, and that shopkeeper will it will take 15 days for him to supply the required quantity of rice. So when you will place the order, your rice supplier is telling that your rice supplier is telling you that, sir, 8 kg rice I can't supply immediately. Only every 15 days once I will be able to send you the rice. So imagine April 1 you need 8 kg of rice. So now when will you order? When you should have ordered? April 1 you require your rice, 8 kg of rice. It takes 15 days for your rice supplier to give you rice, 8 kg of rice. So when you will release the purchase order, or when you will place the purchase order to the supplier?
15 days before only, sir.
15 days before. That is on March
15th, sir.
March 16, 31 days this month. Okay, so March 16th you will be placing the order, so that on April 1 you will get the rice. Correct? Exactly on that day you can get the rice in your home. Correct? So this is what is called as the so when you are deciding when to place the order, you're going to decide that is the time of order. Okay, so when you got a warning signal from your mother or your wife or your roommate to go for purchasing go for the next purchase, you need 10 kg. Now let's speak in numbers. Your roommate or your wife or your mother or someone, your maid, someone, they are telling you to buy the rice. When they will give an alarm, or when they will raise the ticket to buy the rice?
After finishing 2 kg, sir.
After finishing 2 kg.
Because lead time is 15 days is there, sir.
Correct.
15
You're right.
days,
You're right. Okay. So depending upon your daily consumption, they will know that before 15 days, for 15 days, what is your rice consumption? They'll calculate that, and depending upon that calculation, they will tell you that the rice can last for next only 15 days. Now it is the right time for you to place the purchase order for buying the required amount of rice from the supplier, because the supplier is going to take 15 days for you to supply. So they'll know the exact quantity, how it can last for 15 days, right? For 15 days, how much rice is required, that they know. Depending upon that, they're raising a ticket to the purchase manager, that is you in your home, to buy the rice. So you'll place the order on the 15 days before, exactly 15 days before you're placing the purchase order for getting rice, 8 kg rice after 15 days. So depending upon your consumption pattern, the alarm or the ticket is raised to placer. That time, or that optimal time when you have to place the order, is what you call as reorder point, or what you call as economic order. The time what you're placing is called as the reorder point. The quantity, the quantity at which you're placing the order is called as economic order quantity. Are you able to understand? Economic order quantity is what? For 15 days rice, what you have in your hand, that is called as economic order quantity. When the quantity decreases to that level, that is the right time and you're placing the order. That is called as economic order quantity. Okay? Are you able to understand? Okay. Okay, in this economic order quantity system, what will happen is there will be continuous review system, or daily they will check what is the quantity of rice left out in your home. Depending upon that only, they will be asking you to purchase, right? So they know this rice will last only for the next 15 days. Now it is the right time for you to buy this. When they are telling you this is the when they come to know that this is rice will last only for the next 15 days, that is the right economic order quantity. Okay, are you able to understand? அந்த 15 நாளைக்கு எவ்வளவு அரிசி இருக்குன்னு உங்களுக்கு தெரிஞ்சுக்கிறாங்க பாத்தீங்களா? அந்த 15 நாளைக்கு முன்னாடி உங்ககிட்ட சொல்றாங்கல்ல, இவ்வளவு இந்த அரிசி இருக்கு, இந்த 15 நாளைக்கு தான் வரும். நம்ம ரைஸ் சப்ளையரால 15 நாள் கழிச்சு நம்மளுக்கு ரைஸ் கொடுக்க முடியும். அதனால நீங்க இப்பவே ஆர்டர் பண்ணுங்க அப்படின்னு சொல்றாங்கல்ல, அதுக்கு பேர் தான் வந்து எக்கனாமிக் ஆர்டர் குவான்டிட்டி. அந்த அரிசி 15 நாளைக்கு தான் வருதுன்னு முடிவு பண்றாங்கல்ல, அந்த குவான்டிட்டி ஆஃப் ரைஸ் வந்து 15 நாளைக்கு தான் வரும் முடிவு பண்றாங்க, அதுதான் எக்கனாமிக் ஆர்டர் குவான்டிட்டி. நீங்க எந்த டைம்ல போய் அந்த பர்ச்சேஸ் ஆர்டர் பிளேஸ் பண்றீங்களோ அதுக்கு பேர் வந்து ரீஆர்டர் லெவல். புரியுதா? இந்த எக்கனாமிக் ஆர்டர் குவான்டிட்டியை கணக்கு பண்ணும் போது நம்ம கிட்ட எவ்வளவு இன்வென்ட்ரி இருக்குன்னு நமக்கு தெரிஞ்சுக்கணும். ஓகேவா? இது ஒரு பாயிண்ட். ரெண்டாவது பாயிண்ட் என்னன்னா, இன்வென்ட்ரி எவ்வளவு இருக்குன்னு தெரிஞ்சுக்கிறது முக்கியம். இது வந்து நம்ம வீட்டுல சாதாரணமா நம்ம பண்ணக்கூடிய ஒரு வேலை. இதே இது கம்பெனில என்ன பண்ணிருப்பாங்க அப்படின்னா, இன்னொரு வார்த்தை எக்ஸ்ட்ராவா சேர்க்கிறாங்க. அதாவது ரெப்ளனிஷ்மெண்ட் ஆர்டர்ஸ் அவுட்ஸ்டாண்டிங். அதாவது ஒரு கம்பெனில ஒரு பொருள் வாங்குறாங்க, ஒரு சப்ளையர் கிட்ட இருந்து வாங்குறாங்க, நம்ம அதை யூஸ் பண்ணிக்கிட்டு இருக்கோம். இதுக்கு நடுவில் என்ன பண்ணிருக்கோம், நம்ம ஒரு ஆர்டர் போட்டிருக்கோம். அந்த ஆர்டர் வந்து வர்றதுக்கு வந்து 10 நாள் அந்த ஆர்டர் வந்துடும். ஒரு ஆர்டர் போட்டுட்டீங்க, அது வந்து ஷிப்மெண்ட்ல இருக்குது, அது உங்களுக்கு 10 நாள்ல வந்துடும். ஆனா இன்னொரு ஆர்டர் நீங்க போட்டிருப்பீங்க, எதுக்குன்னா அடுத்த 10 நாள் கழிச்சு வேற எதுக்கும் போட்டிருப்பீங்க. ஸோ ஒரு ஆர்டர் நீங்க பிளேஸ் பண்ண முன்னாடி நடுவில் கொஞ்சம் ஆர்டர் வந்துடும். அந்த இதையும் நீங்க கனெக்ட் பண்ணிக்கிறீங்க. புரியுதா? இன்னும் உங்களுக்கு புரியுற மாதிரி சொல்லணும்னா, நம்மளுக்கு 8 கேஜி ரைஸ் தேவைப்பட்டுச்சு. ஏன்னா 2 கேஜி ரைஸ் நம்ம வீட்டில் இருந்துச்சு, 8 கேஜி ரைஸ் நம்மளுக்கு தேவைப்படுது. நீங்க என்ன பண்ணிருக்கீங்க, அதுக்கு முன்னாடி ஒரு 10 நாளைக்கு முன்னாடி ஒரு ரைஸ் ஆர்டர் போட்டிருக்கீங்க. அதுல வந்து ஒரு 5 கேஜி ரைஸ் ஆர்டர் போட்டிருக்கீங்க. அந்த 5 கேஜி வந்துடும். உங்களுக்கு தேவை எவ்வளோ? 8 கேஜி தேவை. 8 கேஜி ரைஸ் தேவை. மொத்த ரெக்யூர்மெண்ட் எவ்வளோ இருந்துச்சு உங்களுக்கு? மொத்த ரெக்யூர்மெண்ட் ஆஃப் ரைஸ் எவ்வளோ இருந்துச்சு ஃபர்ஸ்ட் டைம்?
10 kg சார்.
ஆக்சுவல் ரெக்யூர்மெண்ட் 10 கேஜிஸ் இருந்துச்சு. உங்ககிட்ட எத்தனை கேஜி வீட்டில் இருக்குது ஆல்ரெடி?
2 kg சார். இன்வெர்டர்
2 கேஜி இருந்துச்சு. ஆல்ரெடி நீங்க ஒரு 5 கேஜிக்கு ஆர்டர் போட்டிருக்கீங்க. ஆல்ரெடி ஒரு 5 கேஜிக்கு நீங்க ஆர்டர் போட்டிருக்கீங்க. அப்படின்னா மிச்சம் வந்து நீங்க எவ்வளவு கேஜி ஆஃப் ரைஸுக்கு புது ஆர்டர் போடணும்?
5 kg சார்.
5 கேஜியா?
3 kg சார்.
3 கேஜிக்கு தான் நீங்க ரைஸ் ஆர்டர் போட போறீங்க. ஸோ நீங்க பர்ச்சேஸ் ஆர்டர் வந்து பழைய ஆர்டர் வந்து போட்டுட்டீங்க, 5 கேஜிக்கு போடுவீங்க. புது ஆர்டர் எவ்வளவு போடுவீங்க? 3 கேஜிக்கு தான் போடுவீங்க. இந்த 3 கேஜி எப்போ போடணும்? 15 நாளைக்கு முன்னாடி போடணும். கரெக்டாக? ஏன்னா உங்க ரைஸ் சப்ளையருக்கு 15 நாள் தேவைப்படுது. இந்த 15 நாள்ல வந்து நம்ம லீட் டைம்னு சொல்றோம், இந்த 2 கேஜியை இன்வென்ட்ரின்னு சொல்றோம், ரெப்ளனிஷ்மெண்ட் ஆர்டர்ஸ் வித் அவுட்ஸ்டாண்டிங் ஆர்டர்ஸ் எவ்வளோ சொல்றோம்? இந்த அவுட்ஸ்டாண்டிங் ஆர்டர்ஸ் வந்து 5 கேஜி. ஏன்னா நம்ம ஆர்டர் போட்டு அது ஷிப்மெண்ட்ல வந்துட்டு இருக்கு, அது வந்துடும். இந்த 5 நாள் நம்மளுக்கு 5 நாள் 10 நாளே நம்ம கிட்ட வந்துடும். அது வந்ததுக்கு அப்புறமா எனக்கு 3 கேஜி இருந்தா போதும். அந்த 3 கேஜி நான் என்ன பண்ணணும்? 15 நாள் ஆகும் என் சப்ளை எனக்கு சப்ளை பண்றதுக்கு. அப்போ 15 நாளைக்கு முன்னாடி பண்ணணும். இது எல்லாத்தையும் நான் கணக்கில் பண்ணணும்னா எனக்கு டெய்லி எவ்வளோ இன்வென்ட்ரி இருக்குன்னு எனக்கு தெரிஞ்சுக்கிட்டே இருக்கும். இந்த டெய்லி எவ்வளோ இன்வென்ட்ரி குறைஞ்சிக்கிட்டே இருக்குன்னு எனக்கு தெரிஞ்சாதான் என்னுடைய பர்ச்சேஸ் மேனேஜர் வந்து என்ன பண்ண முடியும், அவரால் வந்து ஆர்டர் போட முடியும். அதுதான் வந்து எக்கனாமிக் ஆர்டர் குவான்டிட்டின்னு சொல்றோம். ஸோ இந்த எக்கனாமிக் ஆர்டர் குவான்டிட்டிங்கிறது இங்கே என்னது? எப்போ வந்து நம்மளுக்கு தெரிய வருது, நம்ம இன்வென்ட்ரி குறைஞ்சிக்கிட்டே வருது, இந்த இடத்துல வந்தோடனே நம்ம வந்து ஆர்டர் போடுறோம். இதை வந்து இந்த இடத்துல இந்த இதுக்கு பேர் வந்து ரீஆர்டர் பாயிண்ட். இதுக்கு பேர் வந்து ஆர்ஓபி, ரீஆர்டர் பாயிண்ட். இந்த இடத்துல வரும்போது ஒரு 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 குவான்டிட்டி இருக்குல்ல, அந்த குவான்டிட்டிக்கு பேர் எக்கனாமிக் ஆர்டர் குவான்டிட்டி. 10 கிலோ தேவைப்படுது, இங்க 0 ஆயிருது. இதை வந்து நான் 20 நாள்ல யூஸ் பண்றேன். 10 கிலோ வந்து நான் 30 நாள்ல யூஸ் பண்றேன். 10 கிலோ ரைஸ் நான் 30 நாள்ல யூஸ் பண்றேன். இங்க என்ன பண்றாங்க, கரெக்டா ஒரு 8 கிலோ வந்தோடனே சொல்லிடுறாங்க, ஓகே இந்த ரைஸ் வந்து இன்னும் வந்து ஒரு 15 நாள் தான் வரப்போகுது. அப்படின்னா இந்த 15 நாளுக்கு முன்னாடி சொல்றாங்கல்ல, அப்போ இந்த 8 கேஜி என்ன ஆயிருது? இதான் ரீஆர்டர் குவான்டிட்டி ஆயிடுச்சு. இல்லை ஏதோ ஒரு 8 10 5 அந்த மாதிரி இருக்குமா அவங்க சொல்லிடுறாங்கல்ல, அதுதான் வந்து என்னது? ரீஆர்டர் குவான்டிட்டி. ஓகே, ஸோ டு கால்குலேட் திஸ் ரீஆர்டர் குவான்டிட்டி we have this formula Q star is equal to 2 into D into CP divided by CH. ஸோ இந்த Q ஸ்டாருங்கிறது ஒன்றும் இல்லை, இந்த EOQ எக்கனாமிக் ஆர்டர் குவான்டிட்டி. டிங்கிறது என்னது? டிமாண்ட். டிங்கிறது என்னது? டிமாண்ட். சிபிங்கிறது என்னது? ஆர்டரிங் காஸ்ட். சிஹெச்ங்கிறது என்னது? கேரிங் காஸ்ட். ரைட்டா? டினா டிமாண்டு, எக்கனாமிக் ஆர்டர் குவான்டிட்டியோட ஃபார்முலா ஸ்கொயர் ரூட் ஆஃப் 2 இன்டூ டிங்கிறது டிமாண்ட், சிபி அப்படிங்கிறது ஆர்டரிங் காஸ்ட். அதாவது ஒரு பொருள் ஆர்டர் பண்றதுக்கு ஒரு காஸ்ட் இருக்குது. ரைட்டா? பர்ச்சேஸ் ஆர்டர் பிளேஸ் பண்ணும்போது அந்த காஸ்ட் அதில் சேர்த்துருவாங்க. ஸோ அந்த ஆர்டரிங் காஸ்ட் அதுக்கு வந்து கொஞ்சம் செலவாகுது. அது போக கேரிங் காஸ்ட்டுங்கிறது ஒரு பொருள் வந்துருச்சு நமக்கு. you got a product at your home, at your warehouse, and you need to save the product for a certain period of time, right? You're storing something in your warehouse. That means what? You're going to take care of the product for holding it, or to hold as an inventory. For example, at the same example, you're buying 10 kg or 8 kg of rice for your home. You can't put your rice anywhere. You're storing it in a place. You're trying to preserve it. You're buying vegetables. You have to put it in a fridge, and you have to spend electricity for the fridge. and you have to spend maintenance of the fridge. So all this includes as the holding cost, or what you call as the carrying cost. Holding cost is solla, or you can also call it as carrying cost. So this is the formula. Please memorize this formula. Q star is equal to square root of 2 into dCp by CH. Okay, or instead of CH they'll use CC, because carrying cost or holding cost or inventory cost. There are three names for this. Okay, hope you noted down this. Next, you have to calculate the ROL. ROL is what? Reorder level. So at what level you have to reorder? Reorder level is what? Average demand during lead time plus reverse stock plus safety stock. Okay, how to calculate reverse stock? It is standard deviation of demand during lead time into service level factor. Safety stock is what? Average demand during delay in lead time into probability of such delay. Okay, so to get back to the old example, rice, right? So average demand during lead time, because it takes 15 days for your supplier to supply that rice, right? So if it takes 15 days time, how much is your rice consumption during this 15 days? That is the average demand, because 15 days is your lead time. In this 15 days of lead time, how much is your consumption of rice? That is average demand. What is reverse stock? It is your safety, it is your inventory. Standard deviation of demand during lead time into service level factor. So standard deviation you have to calculate. I mean, there is I'm not going to just assume reverse stock is what? Standard deviation of demand during lead time plus safety stock, because every company will always maintain a safety stock to open it in the case of emergency. Because if something, say for example, if due to some shipment delay or due to some strike, the components or the supplier is not able to send you the components on right time. So to prevent that, what they will do, they will always have a safety stock. How the fire service people are having stored water in their tankers every time ready, or they'll have the source of water every time ready. So that is what we call a safety stock. Like some of your mothers will have some money, or your wife will, or you will have money under your bed or under your inside your rice bag, inside the sugar dabba or inside a spice dabba. You're storing something, right, which you will not even touch. Only in the case of emergency you will open it and you will use it. So that stock is called a safety stock. Okay, next. So when you know your reverse stock with known stock outs are there, so there is expected inventory cost is equal to carrying cost plus shortage cost. Now we have to do some costing, right? So first you should determine whenever this reverse stock is going to happen, you should determine what is that. Then to calculate expected inventory cost. What is the inventory cost you are spending? That is a holding cost, or the carrying cost is what? Carrying cost plus shortage cost. So this one important formula you should memorize. Okay, then reverse stock formula is reorder level minus DTL. Okay, minus DTL. So the formula here is DLT bar is equal to DLT into probability of demand per units. I'm not going to confuse you with these formulas. Just know how to calculate. Okay. Then service level with unknown stocks is service level is equal to 1 minus probability of stock quote. Again, you remember probability. 1 minus probability, that is 100% is 1 minus what is the stock out chances. So you have to find this with these formulas. So DLT is equal to SD into square root of LD. Okay, just note on this, that's enough. Then how to calculate reverse stock? DLT into Z. Reverse stock is equal to summation of DLT into Z square root of DLT. Okay. So reverse stock we can also calculate reverse stock by using this formula. R of Z is equal to Z into Q. Okay. Sigma is the standard deviation. RS is the reverse stock. Okay. So now let's straight away go to the problem, because problem is easy than understanding the formulas. So the distribution of the actual demand of an inventory system during the firm or lead time is 9 days. So they are given the lead time. Lead time is what? 9 days. It's given to you. Determine the reverse stock when no stock is decided, no stock out is decided. Determine the reverse stock reorder level corresponding to the given. So that is when unknown stock is there, when known stock is there, what they are going to do. So that is the question what they have asked. Okay, don't get confused. உங்களுக்கு புரியலனாலும் பரவாயில்ல, கவனிங்க. இதே மாதிரி ப்ராப்ளம் நம்ம எக்ஸாம்ல கேட்க போறோம். சரியா? So the number of units for the 9 days is given. Okay, the number of items for the 9 days is given, probability is given. Here the number of units is given in some ranges, 51 to 60, 61 to 70, 71 to 80, like in some ranges it is given. The probability is also given here. Okay, now let's see how to do it. So now we are using the midpoint formula. We are doing this. What is midpoint formula? How you calculate this? 55.55 is 51 plus 60 divided by 2. 51 plus 60 divided by 2 will give you 55.5. So did you understand how you got this?
Clear, sir.
Like this, you have to calculate the complete list. Okay, this probability function, it is given in the problem. Same thing we copied here. Then when you sum up this probability function, it should be 1, which we already know, correct? Because probability should be, if you sum up this probability, it should be 100% or 1. Okay, next, probability of this demand or more. For this, what you're doing, you're finding the cumulative. If you find the cumulative, you'll get this 1 plus 0.01 plus 0.04 will give you 0.05. 0.05 plus 11 will give you 0.16. 16 plus 2.0 will give you 0.36. 0.29 plus 0.36 will give you 0.65 plus 0.20 will give you 0.85 plus 0.10 will give you 0.95 plus 0.4 will give you 0.99 plus 1 will give you 1. Okay, just we are taking cumulative. Next, what I should do, I should calculate F into M. F is probability, M is midpoint. So, but here I have to do for the cumulative one. So here I have to do for cumulative one. So 0.01 into 55. 0.05 into 6.565 will give you this answer. So what I'm doing, I'm multiplying this M with this, sorry, this M with this into 65.5. So like this I have to multiply. So when I sum up, what I'm getting, 95.30. Are you able to understand this? First, yes, based upon number of units, you're taking the midpoint. Then you're noting down the probability. Then you're doing the cumulative for probability. And when you do, after taking the cumulative, for the cumulative probability values, you're multiplying with the midpoint value to get the F into M. So this is how you calculate the average. You're doing this. Next, now we know the average demand is 95.30. Okay. Now with this average demand during lead time, average demand is what? 95.30. 95.30. This is a DLT, average demand during lead time is 95.30. Okay. Now we now in this problem, you're saying the maximum number of units is what? 140. Okay, the maximum number of demand during the lead time is 140. So 140 I'm taking, maximum is 140. So reverse stock is what? Reverse stock is maximum DLT minus average DLT. Maximum DLT value is 140 minus average DLT value is 95.30, which is giving you the reverse stock answer as 44.30. Next, there is a formula to calculate interpolation at by interpolation, that is this formula you have to use. Okay, so for 95%, what is the thing? So 95%, because we are calculating for the 95% of service level. So 95%, that will be given you in the problem. So don't worry. So 95% is L plus I into N by 100 minus C dot F into H by FL, where L is equal to 95 and N is equal to 1. So I is equal to 85 and N is equal to 1. So with that, we are calculating as 10, 10 L value is 110.5. Okay, and we are calculating the P 95%. Then reverse stock formula is again maximum DLT for service level is 120 minus average DLT is 95.30, that is 25.20. Okay, so this I will explain you. This I will explain you later. So just you have to note on the formula. This formula you should know. This formula you should know, and you should know this formula. So if you know these three formulas, we will be able to calculate. Or in examination, mostly this percentage value will be straight away given. You don't need to memorize this formula. This for probability for 95% value will be directly given to you. So no need to worry about this. Okay, so that is when you have Q system. When you're having a periodic review system, you have to find the reorder quantity is target inventory level minus inventory level on hand plus previous orders not yet received. That is, this is in shipment. This previous orders in shipment plus inventory. But here again, since it's a periodic review approach, that is once in a 15 days you are going to evaluate, once in a 10 days you are going to check what is the quantity required. So here it is not continuous review system. In Q is continuous review system, P is in periodic review system. Only once in a month they calculate how much is required, what is the requirement. So here we have some target inventory level. So I need to have some inventory as backup. So I'll know what is the target inventory minus what is left out plus what is available in the previous orders. So that is what is give you economic order quantity for periodic review approach. Then the same formula, you know, Q equal to D into DCP by CH. And if you want to find the optimal time, then you can use this formula where the demand will come down. The same formula, but demand will come down. You know, CH is the carrying cost and the CP is the ordering cost and D is the demand. T is the successive time between two orders. So please try to note down this formula. This formula we already know. Okay, so now we'll go over this. Let's go to this problem. So here what they are selling, demand D is 2,500 per year. Demand is given. CP is given. CP is what? Setup cost is given. Lead time is given. Cost per unit is given. CH, holding cost per year it is given. Calculate the sufficient number of orders to meet the demand. So for this, first what we are going to do, we are going to calculate the pre-order quantity. The formula we know, D value is given, CP value is given, CH value is given. So directly you are substituting and finding the Q star value. Number of orders, how will you find? Demand divided by quantity, reorder quantity. So number of orders is like how many times you need 1,000 components. Say for example, you need 1,000 components and you are going to order 250 times, right? Every time whenever your stock drops down to 250, you're going to do the economic order quantity. So if 250 is this, how many number of times you should go for reordering, right? For that's how we calculate. So in this case, the demand is 2,500 because it is given in the problem. So for 2,500, how much times we are going to do? So 2,500 is 10 orders. Then T star formula, you know, T star is equal to 2 CP into D. Substituting directly the values, you'll get 25 days. Lead time is given in the problem as 10 days. So lead time plus the time calculated as 25 days will give you 35 days. Sufficient units to be ordered is equal to T star. That is for 35 days, how many orders you have to place. So that is 35 plus 10 days into N star. N star is 10. So this value we know, T star plus LNT is 35 days into N star is 10, already calculated. So we are getting 350 units. So that's how we do. The next thing is when demand is variable and lead time is constant. So here demand is given same thing, 10 demand is normally demand is normally distributed what you're doing. Again 95%. What is the standard deviation? We know the formulas for standard deviation as this, so you can calculate this. Okay, so the last problem is very easy. The annual demand is 10,000 units. Cost per unit is 5. Inventory carrying cost is given. Maximum delay is 3 weeks. Service level is 95%. Standard deviation is 10. Ordering cost is 150. Average lead time is 4 weeks. Probability of delay is 0.30. And they're asking you to calculate the buffer stock, reverse stock, safety stock, disabled maximum inventory level for this item. So to the review period is EOQ divided by D. That is a formula. So 447 is given. 440. Okay, so it is 447 by 1000. So why 50 days? Because it is 52 weeks. It is 52 weeks per year. So you get 23.2440. So you can either have 23 weeks because we have rounded it off. So you can have as 23 weeks or 24 weeks. So that's why we are doing this for 2 times. 23 you have to shuffling like this. Then for 23 weeks means 52 by 23. That is total number of weeks 52 in a year divided by 23 weeks into 150. 150 is the ordering cost. 150 is the ordering cost. So we get 339.13. Inventory cost is 1 by 2. So 1 by 2 of 1000 orders demand divided by demand divided by number of weeks divided by how many weeks for this 23 into 5. 5 is the cost per unit. Then 0.3 0.30. 0.30 is the inventory carrying as percentage. So we'll get 331.85. Total cost is ordering cost plus carrying cost. You have to add this both, you'll get 60. Same way if you're doing for 24 weeks instead of 23 weeks, you'll get it as 672.22. So that is why when both demand rate and lead time are variable. Okay. So just understand how it is done. Straight away we'll give the values and you can solve it. Okay. So with this we are completing the module number 3. Okay. So our exam, you got the timetable for your midterm examinations.
No, sir. Still no.
Okay, your first exam is starting on 7th. Next Sunday, right? Yeah.
Yes, sir.
Next Sunday you have your examination. So do you want us to have the class on 6th? Next Saturday, do you want maintenance class?
So which subject is there? We don't know, sir. According to that, we'll plan, sir.
I will tell you. On 7th, you are having metrology and measurements. Okay. 7th afternoon, you are having metal forming and machining.